Hello friends, welcome you in my YouTube channel. In this video, I am going to talk about analytical method for measuring biochemical oxygen demand. Generally we call it BOD. I am Dr. Mohammad Sirajul Faisi. So let us start about biochemical oxygen demand. So biochemical oxygen demand BOD indicates the presence of biodegradable organic matter. Indicates the presence of biodegradable organic matter. I repeat, biodegradable organic matter in water quantitatively. So you have the two parameter, qualitative and quantitative. So in BOD we are talking about biodegradable organic matter in water quantitatively, which consume dissolved oxygen from water. Hence it is an index of organic pollutions and indicates suitability of water for a particular consumptions. So BOD is the amount of oxygen. I repeat, the BOD is the amount of oxygen required by bacteria while stabilizing decomposable organic matter under aerobic conditions. I repeat, the BOD is the amount of oxygen required by bacteria while stabilizing decomposable organic matter under aerobic conditions. The decompositions of organic impurities in presence of bacteria results in utilizations of a part of the dissolved oxygen by the bacteria during their respiratory and metabolic activities, and this depletions of oxygen is considered as a measure of strength of water. So organics plus oxygen give carbon dioxide plus water in presence of bacteria. All organic constituents of sewage degrade under aerobic conditions. The organics in sewage can be divided into three major groups: carbohydrates, starch, sugars and cellulose, and second proteins, and third fats. The approximate distributions are organic being 40 to 50% carbohydrates, 40 to 50% protein, and fat is 5 to 10%. The starches and sugar can easily metabolize by microorganisms, while cellulose decompose at a slower rate. So carbohydrate gives alcohol plus fatty acid and then CO2 and H2. The proteins are complex of amino acid, you know that, which form major source of microbial nutrients. So amino acid plus ammonia give nitrite and then nitrate. You see, hydrogen sulfide convert to sulfuric acid. Alcohol plus organic acid give carbon dioxide plus water. Proteins and other nitrogen containing organic compounds undergo enzymatic microorganisms, and fats are degraded by microorganisms at very slow rate. You see, enzyme, fatty acid, glycerol, alcohol, lower fatty acid, and then carbon dioxide H2. So the biochemical oxidation of organic matter in sewage can be considered as a monomolecular reaction given by the linear rate equations. So why is equal to BOD at time t. L is equal to ultimate BOD and K is the reaction rate constants. So L and D both serve as an effective means of gauging and qualitative and quantitative change in decomposition material in chlorinated and unchlorinated and chlorinated samples. A reductions in K in state implies that as a result of chlorination, a quantitative change in the character of sewage constituents had taken place so that they had become less readily decomposable by aerobic organisms. Thus, a K value of 0.2 will exert 90% of its ultimate first stage BOD in 5 days at 20 degrees Celsius, while a K values of 0.15 will have exerted only 32% of its BOD in the same 5 days at 20 degrees Celsius. So, the chlorination of sewage always results in the reductions of L value, which indicates that there is a quantitative change in the decomposable fractions of sewage. So, reagent Kong sulfuric acid, 48% manganese sulfate solution in water, alkaline potassium iodide adds 700 grams of potassium hydroxide and 150 grams of potassium iodide in 1 liter. 0.0125 in a standard sodium thiosulfate solution, starch indicator sodium sulfide. If the sample of sewage or water is alkaline or acidic, then neutralize at pH 7 with 1 in H2SO4 or 1 in sodium hydroxide using pH meter. Excess of chlorine will be removed in sample is allowed to stand for 1 to 2 hours in open. If residual chlorine is too high, titrate it with these solutions and add the required amount of sodium sulfate. Now take 3 bottles ABC of 500 ml capacity and fill the bottle with aerated water and a stopper without leaving any air bubbles. Determine the dissolved oxygen immediately by adding 1 ml of manganese sulfate, 2 ml of Kong sulfuric acid. In bottle B and C, take 1 ml of manganese sulfate solution and 2 ml of Kong sulfuric solution. In bottle C, add 2 ml of sewage sample of. Incubate both the bottle at the room temperature for 5 days. Find the dissolved oxygen of both the bottle B, black bottle, and C, sample bottle by the same method as described. Then do the calculations. 1 ml of 0.0125 N2H2O3 solution is this milligrams of O2, and then use this two formula, and then A minus V suggests loss of oxygen during incubations. So friends, hope this video will be helpful to you. If you like this video, then subscribe my channel, and thanks for watching.